In this example, we have to check whether the following functions are functionally dependent or not. And if so, find the relation among u and v, which are given by u is equal to x plus y upon 1 minus xy. V is given by tan inverse of x plus tan inverse of y. We have to examine for functional dependence of the following functions: u is equal to x plus y upon 1 minus xy, and v is equal to tan inverse of x plus tan inverse of y. We know that the functions u and v are said to be functionally dependent with respect to the variables x and y if Jacobian of uv with respect to xy is equal to 0. Let us take the left hand side of this equation. What is the left hand side? Jacobian of uv with respect to xy. But we know that what is Jacobian of xy, uv with respect to xy? It is nothing but determinant of determinant of partial derivative of u with respect to x means del u del x, del u del y, del v del x, and del v del y. Now u is given by this, v is given by this. Let us try to find out del u del x. So how to calculate del u del x? Now since u is function of x and y and it is in the fraction form and numerator and denominator both are functions of x, so we apply the u by v rule. So what is that? It says that denominator derivative of numerator with respect to x. So derivative of x is 1, derivative of y is 0. So we have only 1 minus numerator. What is numerator? Numerator is x plus y over here, and derivative of denominator with respect to x. So this is 0 and x with respect to x, y minus y is constant. So minus y into 1 whole divided by denominator square. So 1 minus xy whole square. Let us simplify this one, 1 minus xy, and this minus minus will become plus xy plus y square. So minus xy and plus xy will cancel. We have 1 plus y square upon 1 minus xy whole square. Similarly, what is the partial derivative of u with respect to y? Again, the same thing is happening over here. Numerator and denominator both are functions of y. So we have to use the u by v rule for the differentiation. So denominator, derivative of numerator with respect to y is 1 minus x plus y numerator into derivative of denominator 1 minus xy with respect to y, which is minus x, whole divided by 1 minus xy whole square. And now if we again simplify it, 1 minus xy minus minus will become plus x square plus xy. Now this minus xy plus xy will cancel. We have 1 plus x square upon 1 minus xy whole square. So these are the derivatives of u and u with respect to x and y, partial derivatives. Similarly, what is the partial derivative of v with respect to x? So derivative of tan inverse of x is nothing but 1 upon 1 plus x square. And since this is free from x, so its derivative will be 0. Similarly, if you want to find out the partial derivative of v with respect to y, this is constant, so its derivative is 0. And what is the derivative of tan inverse of y? It is 1 upon 1 plus y square. Now we have to substitute all these values. So the del u del x is 1 plus y square upon 1 minus x whole square. Similarly, del u del y is 1 plus x square upon 1 minus xy whole square. Del v del x is equal to 1 upon 1 plus x square, and del v del y is equal to 1 upon 1 plus y square. Let us try to solve this determinant. So now we have to multiply this cross multiplication, this into this minus this into this. So we can write down 1 plus y square into 1 upon 1 plus y square minus 1 upon 1 plus x square into 1 plus x square into upon 1 minus xy whole square. So this 1 plus y square, 1 plus y square, 1 plus x square, 1 plus x square will cancel. And we have the remaining term 1 upon 1 minus xy whole square minus 1 upon 1 minus xy whole square. Both are again similar. So answer is 0. And this is nothing but the right hand side which we want to prove it. Since the Jacobian of UVW with respect to XYZ is 0, so the given functions are functionally dependent. Now, since these are functionally dependent, so let us try to find out the relation among the given functions. Now, we have to find the relation among the given functions. U is given x plus y upon 1 minus xy. V is given tan inverse of x plus tan inverse of y, which is given as equation number 2. Now, from equation number 2, we have V is equal to tan inverse of x plus tan inverse of y. But we know that tan inverse of x plus tan inverse of y is nothing but tan inverse of x plus y upon 1 minus xy. So this can be written as tan inverse of x plus y upon 1 minus xy. And this is nothing but u. So it can be written as tan inverse of u from equation number 1. And if we take in this side, so what is the value of u? U is equal to tan v. So this is the desired relation between the given functions u and v. Thank you.